Alright, so I'm going to finish the review here. I started this problem, but I'll restart it. Alright, so we have this problem, and it wants us to solve it, and it wants us to write our answer in terms of a logarithm and as a decimal rounded to nearest thousandths. So again, we have the problem 2 to the 3x equals 24. Again, we got to get this x out of the exponent, alright? So we got to get rid of this 2. So the way you get rid of 2 is log base 2. So we do log base 2 of this side, and we do log base 2 of this side. These cancel out, so we're left with 3x equals log base 2 of 24. Now we got to get rid of the 3, so we divide by 3, and we get x equals log base 2 of 24 divided by 3, and that is your logarithm answer. So that is one of your answers. Now, we have to continue and get the other answer rounded to the nearest thousandth. Alright, so we've got to put this in the calculator. Alright, putting this in the calculator looks like this. We've got to use our change of base formula. So I got to do log 24, enter, divide it by log 2, enter, and then I got to divide that by 3. Divide it by 3, enter. And I get my answer. Approximately 1.528. That is the other answer. Alright, since you're probably not going to have a graphing calculator for this, I am going to eliminate this problem. You don't have to do this. Really, all you were doing putting it in the graphing calculator and look at the graph, but I don't know that you're all going to have graphing calculators, so I'm going to eliminate that one. Won't be on there. Alright, this one you can do. Alright, so we're f of x function, and I'll use colored pens to do this. So our f of x function is the square root of x minus 3. Remember what this minus 3 does is it shifts it. Alright, and opposite of what we think, so it's going to shift it 3 places to the right. So if I do my xy axis here, and here, alright, so we'll do this with the purple. Alright, so it's going to move it over 3 places. So 1, 2, 3, and remember what it looks like. Looks like this. So it looks like this. And that is this graph. Square root of x minus 3 looks like that. This one, we have this absolute value of x minus 5. So again, it's going to shift it 5 places to the right. 1, 2, 3, 4, 5. So it's going to be here. And our absolute value, don't forget what our absolute value one looks like. Alright, it looks like we have a 1 out front. So again, our vertex is here. It's going to go up 1 over 1 in both directions. So it's going to go like that, and it's going to go like this. Alright, so that's our absolute value one. Now they want us to identify the solution set. Again, if we find the solution set where they intersect. So we have a point of intersection right here, which is 1, 2, 3, 4, 1. So 4, 1 is one point of intersection, and the other one is 5, 6, 7, 1, 2, 7, 2. Alright, those are our points of intersection. So 1, 2, 3, 4, 1, 5, 6, 7, 1, 2, 7, 2. So those are our points of intersection. Alright. Number 19, we have to find the inverse for this given function. Again, first thing we do is we make this into a y. We switch x and y. And now we solve it for y. So we're going to add 9, gives us x plus 9 equals 3y, and then divide by 3. Divide by 3, So we get y equals x plus 9 over 3, and that is the inverse. So we would write it as f to the negative 1 of x equals x plus 9 divided by 3. Alright, and then this one, same thing, make that into a y. Switch. And then solve. So we subtract 3, alright, and that gives us y over 6 equals x minus 3, and then we're going to multiply it by 6. Multiply by 6. They cancel out. We get y equals 6x minus 18, and that's our inverse. So f to the negative 1 of x equals 6x minus 18. Alright, so those are our two inverse functions. Alright, 21. Again, it's finding the inverse, so we're going to switch, make this into a y, and then switch. So we're going to start off that x equals y squared plus 1 over 4. We have to get rid of the 4 first, so multiply by 4. So we get y squared plus 1 equals 4x, and then we're going to subtract 1, so we get y squared equals 4x minus 1, and then we got to get rid of the square, so we square root, they cancel out, and we get f to the negative 1 of x equals the square root of 4x minus 1, and that would be G. Alright, and then we got to use this graph, alright, to answer the following questions. Alright, first question is, what is the x-intercept? Well, here's our x-intercept. It's going through the x-axis at positive 1. So 1, 0 is the x-intercept. Alright, the next question is, for what values of x is f greater than 0? So that means when is the function, when is this function above the x-axis? So here, let's do a color, alright? So this green, this is above the x-axis, this part of it, alright? Now that part of it is when x is less than 0, okay? So when x is less than, 1, right? Because it's going through the x-axis here at 1, so here it's above. So whenever it's less than 1, all right? And then we have another part. This part is above the x-axis, and this whole thing is above the x-axis, and that whole thing is when x is greater than 2. All right, so it's above the x-axis when x is less than 1 or x is greater than 2. All right, and then this question says when is the function below the x-axis, less than 0. So the only place it's less than 0 is here. All right, this part right here. So, and that part happens when x is between 1 and 2. So the easiest way to do that is do 1, 2, less than signs, and x. And there's our answer. All right, and then it says, for what values of x is f increasing? Well, remember, we always read these from left to right. So this function is decreasing the whole time here, and it's decreasing the whole time here. So this one is never decreasing, and we would say that. All right, f is never increasing. All right, it's a decreasing function. All right, and then there are applications. This is our last problem. So this one is in that form. All right, the one we got, it's the exponential forms. All right, exponential growth, exponential decay, that's the form. And remember what that form says, that this is a sub 1. All right, so the first question is, what was the population of the city in the year 2000? Well, this is since 2000, so this wants the answer for a sub 1, which is 350. And now it says that the answers are in thousands, so we have to add 3 zeros to it. All right, so 350,000. So that should be an easy one for you. Again, you just take this number and it's in thousands, so you add 3 zeros to it. All right, now this one says describe the city's rate of change, or the rate of change of the city's population. All right, that means they want to know this part. All right, so we want to know how much bigger than 1 is this. Well, this is 0.04, and it's bigger than 1, so that means it's going to be an increase. So we have to change this to a percent. All right, change 0.04 to a percent, move it over 2 places, so it is a 4% increase, or it's increasing by 4% is what we can say. All right, and then the last part, we want to know if it's exponential growth or exponential decay, and explain. Again, that is just looking at this number. All right, this number is bigger than 1, so that means it is exponential growth. All right, 1.04 is bigger than 1, so we're going to say that it's growth, and we're going to say that 1.04 is bigger than 1. That's the explanation. All right, and that's it. And don't forget, I'm gonna put those problems from 9.6 on here too. So that's the only ones that aren't on this review.